26E. Number 1. In Tart's experiments, the null hypothesis says that what was the null in the Tart experiment? So what the whole point of this experiment was to prove that ESP is real, right? So momentarily he assumed that it wasn't. So the expected value in in the box was, after 7,500 draws, was 1,875, right? Now the sample had 2,006, which made him really excited because that's higher than the expected value. So the null hypothesis says that 1,875 is the expected value. Okay, and the alternative, so okay, so number 1, in Tart's experiment, the null hypothesis says that the data are like 7,500 draws from the box 0001, or the box 001, or the fraction of ones in the box, or the fraction of ones of the draws, or ESP is real. Which one? The first one. Okay, there are 3 zeros and 1 1 in the box. Okay. 6. Another ESP experiment used the 10-choice trainer. This is like the Aquarius, but with 10 targets instead of 4. Suppose that in 1,000 trials, a subject scores 173 correct guesses. Set up the null hypothesis as a box model. What would be in our box? 1 1 and 9 zeros. Okay. So the null hypothesis would be in 1,000 draws. So in 1,000 draws, the null should be equal to, how many ones should we get in 1,000 draws? A tenth of 1,000. So 100. Now the alternative, are we going to say higher or lower? Well, it depends what happened in the sample. They scored 173. So the alternative hypothesis is more than 100. Okay. Now, we don't have an SD. Why do we not have an SD given to us? It's a 0-1 box, right? If it's a 0-1 box, the SD comes from the box itself because there is no SD, right? We made 1,000 draws, and 173 of them worked, and the others didn't. So we need to do the SD shortcut, square root of 0.1 times 0.9. Oh. I'm sorry. I should read the question, huh? Yes. So B is the square root of 0.1 times 0.9. So the SD is 0.3. Okay. Now, if we want to do a z-test, then we have to create a z-score. And in order to create a z-score, we need the SE. Which SE do we use? SEN. So in order to do the z-test, I'm going to put 100 in the middle, and I'm going to put 173 over here. Okay. Now, if we want ESP to win, then this area needs to be smaller than 5. If we want ESP, we want this to happen. which means we want our z-score to be very large. When our z-score is very large, our area is very small. Okay, so I take 0.3 and I multiply it by the square root of 1,000 to get the SEN. So times the square root of 1,000, and I get 9.48. Okay, so 173 minus 100 over 9.5. So 173 minus 100 is 73 divided by 9.5. And I get a z-score of 7.68. What is the p-value, meaning the area to the right of 7.68? 0. Okay? Does this research suggest that ESP is real? Yes, because we reject the null hypothesis and we accept the alternative. Now, I still don't believe in ESP. Something must have tipped them off. Okay? And is a z-test 100% true? No. Right? This is considered highly significant because we're less than 1%. But even then, there's still room for error. There's still chance error. Okay, what do you conclude? E, not chance variation. Something else will probably work. Either ESP is real or there was some other thing that tipped them off. Okay, because they weren't anywhere near 100. A z-score of 7, that's almost impossible. Okay. Are we getting the hang of this? All right, number 7. A coin is tossed 10,000 times and it lands head 5,167 times. Is the chance of heads equal to 50%, or are there too many heads for that? Okay. Is this coin fair or not? That's what we're asking. So what goes in the box? 1, 1, and 1, 0. We really like this box. How come? The SD is 0.5. So my expected value, do we want to do SEN or do we want to do SEP? SEP is always easier. So my expected value, I'm going to change my box, 0.5 and 0.5, right? Half ones, half zeros. So my expected value is 50%, and I actually got, my observed value is 51, oh no, sorry. Yeah, that's right. 51.67%. Okay. So I draw my curve. 50% is my expected value. 51.67 is my observed value. Okay. So my null is equal to 50%, and my alternative is greater than 50%. Okay. And then my SD is 0.5. And then my SEP is going to be 0.5 divided by 100, square root of 10,000. So 0.5 divided by 100 gives me 0.5%. So 0.5%. Okay, well, what is the z-score? It's going to be 51.67 minus 50, which is 1.67, divided by 0.5. So 1.67 divided by 0.5, and I get a z-score of 3.34. So now we need a p-value. How do we find the p-value? Shade norm from 3.34 to 5. Now I already know the answer. Why would I do this? The difference between significant and highly significant. I mean, I already know that I'm going to reject the null. So area is 0.0004. So the difference is highly significant because my z-score was so big. So you would say that the results differ from the are highly highly significantly different from the expected value. So we are we are very confident that this is an unfair coin. Okay, and it's kind of weird to fit that in, but this is a highly significant result. We can really trust this, that the coin is unfair. Yes, there are too many heads to say that the coin is fair. Yep. Wait, this difference cannot be explained by chance variation. But there is always that, that really small chance that it happens that way. It would be extremely unlikely for that to happen. Okay, same thing, but we're going to change this 1 to a 0. So now we don't really need to redo much. Now we just need to do 0.67 divided by 0.5. So 67 divided by 50 gives us a z-score of 1.34. It could be, and what's the breaking point? It's 1.66. So we're going to shade norm, and we're going to go from, yes. Yeah, if your z-score is bigger than 1.66 or negative 1.66, then you are outside of the 95% window. Okay, but wait a minute, I thought a 95% window was +2 and -2. Well, that's a two-tailed window, right? If 95% is in the middle, then each tail, then you'd be 2 away, and each tail would contain 2.5. But if the right side tail contains 5%, that z-score needs to slide towards the middle a little bit. Okay, and actually, you can do two-tailed z-tests. They're kind of weird. It would be like saying, this coin is unfair, but I'm not going to say whether it's too high or too low. I'm just going to say it's not 50%. And then in that case, you would have 2 tails instead of 1, but which doesn't really make much sense. Okay, so 1.34 to 5. And then I look at the area, and my p-value is 9%. What does that mean? We landed inside the null area. So we say that we accept the null and reject the alternate. So is this coin fair? We think so. Or rather, we don't know enough to say no. Okay? The mistake, the error could be explained by chance variation. Okay? So 5,067 is not significantly higher than 5,000. Did that help, Malone? So 5,067 is not significantly higher than 5,000. But 5,167 is significantly higher than 5,000. Okay. We're done.